This is question 2 in Leaving Cert Higher Level Applied Maths 2023. It starts off being a Dijkstra's algorithm question. We essentially have to find the shortest path between x and y, which seem to be, well, entrances to the campus. So, essentially just x and y, and we have to find the shortest distance between them. So, we're going to start at x, and we have to consider everything going out of x. So, we have to have priority here. So, x is the first one we pick. So, x has priority 1 and final value of 0. So, we can either consider going from x to a, which is 3400, x to b, which is 2500, or x to c, which is 1250. So the smallest one of all of these is c. So we're going to have c next. This says priority 2, final value of 1250. Now, we can go from c to b, which is an extra 900. So 1250 plus 900 is 2150. So we can actually erase this off. So this is 2150. Or we can go to f for 3900, which is 5150. Now we can't make any more progress, so we're gonna have to select the next shortest one, and that's gonna be b. So b has priority 3. Final value of 2150. Now from B we can go to F for another 2150, which is 4300, which is smaller than 5150, so that's going to be 4300. So this one we've considered. Or we can go to G for 4200, which gives G a value of 6350. I should have labeled these off. So B is labeled off, C is labeled off. Usually I put crosses through. Actually, yeah, I'll put crosses through. So X gets a cross through, B gets a cross through, and C gets a cross through. Okay, so we can't make any more from B. Or I'll actually highlight this. So the next shortest is A, 3400. So A gets priority 4, final value 3400. So from A we can go to D for 2650. So 3400 plus 2650 gives D a value of 6050. Or we can go to E for 800, which would be 4200. So A is now crossed off. Next shortest appears to be E at 4200, so E gets selected next. Priority 5, final value of 4200. Now the only place you can go from E is D for 1750. So 4200 plus 1750 is 5950, which is slightly better. So this becomes 5950. And that is E gone. So now we have D, F, and G to pick from. The smallest being F. So F gets picked next. Priority 6, final value of 4300. Now from F you can either go to H or I. So to H, that'll be a total of 5900 from the start. And here it'd be 6500 to I. 6500. And then that cancels out. So we have D, G, H, and I to pick from. The smallest being H at 5900. So H gets picked next. Priority 7. Final value of 5950. No, why am I saying 5950? It's 5900. There's no 50 there. So 5,900. Don't know why I thought 5,950. So from H we can either only go to G or I. Now going to G would be a waste because that's 1,300 and that's clearly more than 6,350. And the same thing going in here, you get 7,000. So we actually we've considered these paths, but we're not taking them. And we've considered H disappeared. So X, CBA, E, F, and H are gone. So the next one to pick is D at 5,950. So D gets priority 8, final value of 5,950. Now from D we can go to G, which just about isn't worth it. Plus 650 would be 6,600. However, we can go directly to J, which will give us 8,950. And nowhere else. Okay, we've considered this path, but we're not taking it. And that leaves D checked off. Now, next smallest is going to be G at 6,350. So priority 9, final value of 6,350. So from G, we can only go to K, which would give us a value of, so 6,350 plus 2,500 is 8,850. So K gets 8,850. And we've considered this. And we're also marking off G. Nowhere else to go. So the next smallest is I, because we've I, K, and J, but I is the smallest. So I, priority 10. Final value of 6,500. So from I we can go to L for 4,750, which is 11250. Or you can head to K, which is 8,850. So both of these are actually the same. So it doesn't matter kind of which way we go, but the value is still 8,850, and we're going to mark off I. Now, next smallest we have is K. So K is priority 11, final value of 8,850. Now, from K we can head to J, which isn't viable. Or we can head to M, which is 2,400. So 8,850 plus 2,400 is 11,250 again. And that leaves off, or that ticks off K. Because, or no, hang on, going to L, whoops. So 8,850 plus 950 is vastly better, so that'd be 9,800, which is now L's new value of 9,800. And that takes off K then. And I forgot to draw this root. So I only have a few more edges to consider. Next priority is J at 8,950, so I don't have to do it in here. So J, priority 12, final value of 8,950. So you can head to M for 950. 8,950 plus 950 is 9,900, which is vastly better. So 9,900 total. And that's the only way we can go from J that we haven't considered, so that's going to disappear. Now we have L and M to consider, L being better. So L gets priority 13, final value of 9,800. So from L we can head to N or Y. So we go 9,800 plus 1,950 for N, which gives N 11,750. Or we can head directly to Y for 12,100. So that's these two considered. Now, M is clearly the next shortest, so M gets priority 14, final value of 9,900. Now, 9,900 plus 1,550 is 11,450, which is better. So this goes to 11,450, and we've considered this, and now we're gone. Now the only arc we haven't considered is from n to y. Now we don't have to go through our process of assigning priorities again, because we can go to n, which optimally is 11,750, and going 1800 will not get us down to 11,450. So we've considered that arc, yeah, but we're just not gonna consider it. We are going to consider it, we're just not going to label it. So, that's the forward part of the algorithm completed. The second part of the algorithm is going backwards. So, for this, I'm just going to select a different color temporarily. So, I'm going to select, let's say light blue. So, in going backwards, well, 11,450 minus 1,800 is not that. 11,450 minus 2,300 is not 9,800, but we know that 11,450 minus 1,550 is 9,900. So this arc is part of our solution. So I'll actually do it kind of jagged. Now, going from M to K is clearly not 2,400 in that way, but 9,900 minus 950 is indeed 8,950. Similarly, going here, that's 3,000. Now, 5,950 minus 2,650 is not 3,400, but 5,950 minus 1,750 is 4,200, which is down here. And you know that minus 800 will give us back to 3,400, and now back here. So now we just have to follow. I'll put this back to black. We now have to follow where that's going. So the optimal path is X A E D J M Y, and the final weight is 11,450. Doesn't give us any units. Cost in euro, so I'll just rewrite that. So the cost in euro is 11,450 euro. Okay, that's that Dijkstra algorithm question done. Huzzah! Right, now I have a collisions question. So you have two smooth spheres, P and Q, equal radius of mass m and 2m. P and Q collide obliquely. The line joining the centers of the point of impact lies along the y-axis. Yada yada. It's just fine. For the collision sphere, P moves at velocity 4, angle alpha, sine alpha is 4/5. Okay. So I'll just kind of sketch my own diagram, as I tend to do. So we have two smooth spheres, so there's going to be no friction, and there's going to be no sound energy lost either. Let's draw the axes. So we'll label these P and Q. This one comes in with a velocity 4. So 4 meters per second. And these are alternate angles, so I'm going to move alpha down here. And then you have Q coming straight up, velocity 3.2. Now, splitting this up into components, I'll actually change this off because I don't actually need it. I'll go to green. Why not green? So, we have our triangle, because we're given sine alpha. So sine alpha is opposite over adjacent, so that's 3. So we know that cos alpha is 3/5, sine alpha is 4/5. So 4 times 4/5 is 3.2. And by 3/5, oops, wrong way around. So this one should actually be the bottom, so that's 2.4, and this is 3.2. So this is actually our U, or U1, and this is U2. Oh no, U2 is actually 0 because there's none in here. There's no velocity within the direction in which the collision is actually occurring, so U2 is 0, and this is, so P is of mass m and Q is of mass 2. Okay, Now we have to do some simultaneous equations work. So we're going to start with the principle of conservation of linear momentum. So it's always a good idea to write down all your formulae. So we're going to consider P as 1 and Q as 2. So M by 2.4 plus 2M by 0 is M times V1 plus 2M times V2, where V1 and V2 are the components of the velocity after collision. So we can cancel out the M's, and we're left with the V1 plus 2V2 is 2.4. And this is equation number 1. Next we have Newton's law of restitution. Now we're actually not given what the coefficient of restitution actually is. So we just have to do it generally. So V1 minus V2 is minus E times, now U1 minus U2 would be 2.4 minus 0. So V1 minus V2 is minus 2.4 E. And this is equation number 2. Now if we put equation number 1 under here, we have V1 plus 2V2 is 2.4. If we subtract them, we get rid of the V1s. So minus 1 minus 2, so it's minus 3V2 is minus 2.4E minus 2.4, which I'm gonna write as minus 2.4 times E plus 1 for ease of use. And of course these can both be turned into pluses, and we can write the V2 is 0.8 times E plus 1 meters per second. Now if we put this into, say, equation 1, so I'll just write into equation 1, I'll just write over here. So that'd be V1 plus, now 2V2, this would be 1.6 E plus 1 is 2.4. Expanding this out, we get V1 plus 1.6 E plus 1.6 is 2.4. So if we subtract everything onto one side, 2.4 minus 1.6 is 0.8 and minus 1.6 E. If we now factor out 0.8, that's 1 minus 2E. Now it's telling us for the velocities. So we can say over here that V1 in vector form. Now V1, we have a 3.2 in the J, so that doesn't matter, so that can be it. So V1 is 0.8 times 1 minus 2E in the I direction, plus 3.2J, if I remember correctly, yeah, 3.2J meters per second. And then V2 is 0.8 times E plus 1 I, and again plus 3.2J because that was travelling directly upwards before the collision. And those are the answers to question 2 of the higher level applied maths paper.